Welcome to Math Simplified by HM. Have a great session, everyone. We know the rule of the right angle triangle, but today we prove the logic in reverse with the converse of Pythagoras theorem. To stay updated on more math secrets, subscribe and hit that bell icon, and please like and share this with your peers. Grab your notebooks and pause whenever you need a moment. Let us get started. Proving the converse of Pythagoras theorem, a step-by-step geometric deduction. Reversing the flow of logic. If we know the angle is 90 degree, we have c square is equal to a square plus b square. Now, if we know c square is equal to a square plus b square, then the angle must be 90 degree. And this is we have to prove. Let us read the theorem statement carefully. Converse of Pythagoras theorem. In a triangle, if the square of one side is equal to the sum of the squares of the remaining two sides, then the triangle is a right angle triangle. According to this converse theorem statement, what is given? In triangle ABC, the square of the one side equal the sum of the squares of the remaining two sides. That means AC square is equal to AB square plus BC square. And we have to prove angle ABC is equal to 90 degree. The triangle is right angled. We cannot use the Pythagoras theorem on triangle ABC because we do not know if it has a 90 degree angle. To prove angle B is equal to 90 degree, we need a comparative baseline, a dummy suspect. We must artificially construct a perfect right angle triangle to compare it against. The construction trick now. We have in triangle ABC, side AB, side BC and side AC. So now we construct another triangle PQR such that PQ is equal to AB and QR is equal to BC and angle PQR is equal to 90 degree. Now we will evaluate the constructed triangle. Look at our constructed triangle PQR. Because angle Q is 90 degree, by our construction we can apply the Pythagoras theorem. Therefore, PR square is equal to PQ square plus QR square. Substituting the known lengths, recall our construction rules. We have PQ is equal to AB and QR is equal to BC. Let us swap these into our new equation. We get PR square is equal to PQ square plus QR square as equation 1, and when we replace PQ and QR with AB and BC, we get PR square is equal to AB square plus BC square. Name this as equation 2. Now bridging the two equations, given AC square is equal to AB square plus BC square, and we have derived PR square is equal to AB square plus BC square. Now, because the right sides are identical, the left sides must be equal. Therefore, AC square is equal to PR square. Taking square root of this equation, we get AC is equal to PR. Name this as equation 3. Now, we will move to proving the congruence. Now in triangle ABC and in triangle PQR, side AB is equal to side PQ by construction. Also side BC is equal to side QR by construction, and side AC is equal to side PR proved in equation 3. So result is that triangle ABC is congruent to triangle PQR by SSS congruence test. Now final conclusion, because triangle ABC is congruent to triangle PQR, all corresponding angles are equal because corresponding parts of congruent triangles are equal. Therefore, angle ABC is equal to angle PQR. Since angle PQR is equal to 90 degree by our construction, so final conclusion, triangle ABC is equal to 90 degree. The converse of the Pythagoras theorem proved. And that's how we logically prove the converse. Remember, logic and hard work always stand the test of time, just like the theorems we study. Thanks all. Just as the converse proves a triangle is right through logic, your reason and hard work will always stand the test of time. Thank you for joining me today. To support the channel, please like this video and share it with your friends and colleagues. Make sure to subscribe and click the bell icon for more math made easy. Enjoy the great time everyone. See you next time.